Okay, so hi everyone. Yeah, again, my name's Lyle. I'm a structural engineer, so I'm looking at it sort of from the structural engineering perspective. We're not going to be able to completely engineer a house. You need, in order to do that for an individual house, you need to have an engineer or an architect or an experienced contractor come and look at the specific aspects of the house and understand the load path and everything. But what I'll do is touch on general aspects that you can do to essentially strengthen your home. And I'll sort of try to put them in the order that I think is most important. So I've actually taken the figure that Barbara showed earlier, the figure of the sort of general house, and I've rearranged the various items that you can do to strengthen your home in the order that I think of sort of structural importance. And the first one is your windows and doors. And so I think the most important thing you can do is protect your windows and doors and prevent them from becoming openings that air and debris and everything and moisture can get in. And that's going to give you basically the best protection. That's for both the main windows and doors to the main house as well as the garage. The garage door particularly is more vulnerable than most of the other windows and doors in the house. Then the next things really start from the top of the structure and work their way down. And that's mainly because the top of the structure is the lightest part and so the easiest part to lift off. As you work your way down through the house, if it's connected together, then it's getting heavier and heavier and therefore harder to damage. And so we basically start with the roof sheathing, the roof cladding, and then we work our way down into the walls and we connect and make sure we connect the roof to the walls, and then work our way through the second floor if you have a second floor and down into the foundations. So the reason that wind particularly is, I'm going to touch mainly on wind damage, but a little bit on flood damage at the end. The impacts that wind have on a house is kind of demonstrated nicely by this little diagram here. On the windward side, so the direction that the wind is coming from, and this will change over the course of a hurricane. It might come from one direction at the beginning, and then as the hurricane moves around, it could come from the opposite direction. So, but you can consider the side that the wind is currently coming from is basically pushing on the wall of the house. And so you're going to have essentially a positive pressure trying to push that wall in. On the opposite side of the house, you're going to have a suction, basically trying to pull the wall out. And that's basically with the flow of the wind around the house. It's going to try and suck that back side. But what you also see is that it's generally going to try and lift the roof. Sometimes it will push down on the roof, but most of the time it's going to try to lift the roof. And the reason why that's a problem is because in general your roof is designed for gravity, so it's designed for forces acting down on it. When you suddenly reverse those forces and you have it lifting up, particularly on an old house that isn't designed to current building codes, then it can lift the roof off and cause damage. But we can tie it down and try to prevent that. But the other kind of action that we have here from the wind is this internal pressure. And this is the reason why protecting your windows and doors from a structural perspective is very important. If you let air come into the house, it's going to create internal pressure, and that's going to add to the forces from the outside trying to lift your roof. So you're going to have outside forces trying to lift your roof as well as inside forces also trying to lift the roof. And it's going to essentially double the loads on the roof. So that's why by protecting the windows, you're also protecting the roof, and you're protecting the walls, and you're protecting other parts of the structure. And I've got a good photo that kind of demonstrates this a little bit later. So if we start with the windows, because this is a historic house, if we have non-hurricane rated windows in a newer house, what we might want to do to increase their strength is just replace the windows. But because we're talking mainly about historic houses here, then window replacement is less desirable. Unless it's maybe a very new historic house or a very new older house, if that makes sense, then maybe window replacement makes sense. But we're trying to look for ways of protecting the original windows. And so one way to do that, first of all, is to replace the glass in the windows. And again, if it's a very old house and it has old historic glass, you may not want to do this because that's going to damage the original, the historic character of the house. But if it's sort of a 1950s or post-World War II era house, then typically, as Barbara will attest, the glass is sort of similar to modern day glass. It's monolithic typically, but it's usually flat and it's kind of similar to what we would use in modern day glass. So we can essentially improve that by replacing that monolithic glass with a laminated glass, a similar kind of glass to what you have in the windscreen of your car. And that basically is two pieces of monolithic glass that have a membrane in the middle, and it is all sandwiched together and connected together. So you have this membrane in the middle of your glass sheet. This is an example of a test trying to damage a hurricane-rated glazing, and you can see the glazing will still break if a tree branch or some type of debris comes and hits that glazing. But what it will hopefully do is hold that piece of glass together. It will prevent most of the moisture getting through it, and it will prevent that pressurization of the building that I just talked about. The bonus of an important thing for this to be effective is that your frames have to be strong enough to really withstand having the higher pressures on the glass. So if your window frame itself is weak, then doing this probably doesn't have much effect. So you sort of got to assess that. But another bonus of doing this glazing replacement is that you're going to get better energy performance. So the membrane that's inside that glazing will also have energy characteristics which will improve reduce the amount of energy, amount of cooling that you're going to need in your house. So you're getting kind of double duty with that. Now, if glazing replacement is not very practical, another option is to put the film on the inside of the original glazing. And it should go on the inside for the reason that if you have a piece of debris from the outside and it hits that glass, it's only really going to be effective if that membrane is on the inside face. If you put it on the outside face, it will be good from an energy standpoint, but it won't be all that effective from a structural standpoint, protecting your glazing. One manufacturer that provides this type of a membrane that you can put on the glazing is Luma, and they have a website that has some information. In order to make it even more effective, you can actually apply structural silicone around the outside up against the frame, and that'll actually help the edges of that membrane from holding to the frame. Or you can actually partly deconstruct the frame and get the structural silicone in underneath the frame. That'll improve it a little bit further. You're also getting the energy performance out of this membrane, so you're getting double duty there. And the good thing is that many of the window tinting companies, they might be primarily automobile window tinting companies, but many of them will do this for residential or commercial properties as well. So there is many companies out in Hawaii that will actually do this. Now the next one is also in protecting your windows and doors. We want to protect the doors. Most doors, particularly in historic houses, if you've got solid wood doors, they're actually going to be pretty strong. The main weaknesses are really going to be how they're connected to the frame through the hinges and the latches. And so normally we want to have at least 2 latches on a door so that if one latch breaks or the frame around one latch breaks, then you've got a second latch. So that's one way of improving the door performance. And if the frame around the door is not very strong, there might be opportunities to strengthen that, and that might improve it. Garage doors are probably the most vulnerable, and this is an example of a garage door that was blown in a hurricane in Florida. You can replace a conventional garage door with a hurricane rated garage door, and this is an example of one that is hurricane rated. You can see it's got these very strong horizontal members that are part of the door that will basically span from one side from the rails on either side of the door, and that'll if you have that type of door, that'll strengthen it significantly. Now, there's one interesting thing I like about this photo if you look very carefully, but it demonstrates the point I made earlier. Because this garage door has blown in, you can see most of the house is actually in pretty good shape. There's a few roof shingles that have come off, but what you can see is that at the garage, the roof is actually lifted off. And that demonstrates the point I made earlier. Because the garage has been pressurized, it's increased the load on the roof, and it's caused this roof to lift off. Whereas the rest of the house, where the windows, it's not really shown in this photo, but the windows and doors are mainly intact, it didn't get pressurized and the roof is okay. So it sort of just demonstrates that point. Next thing is the roofing material, or the roof sheathing material. As Barbara mentioned, there are high wind-rated asphalt shingles that you can use to replace your conventional asphalt shingles, so that might be a relatively inexpensive way of improving that. Concrete and clay tile roofs, there are ways of adhering a historic tile down to a roof substrate. So that's one option that Barbara mentioned. Other types of tiles, if you're replacing the tiles with a historically similar tile, there are a number of options that use screws that screw the tile down. And the way that these tiles work is they have the screws sort of down sort of near the middle of the tile. So there's kind of an overhang which the weather will see, but then underneath the layer of tiles you'll have some screws, and then you'll have like this back span towards the head of the tile, which is what sort of provides that. The tile will try to lift by cantilevering kind of off the roof, and by having that sort of back span in behind the screws, that will sort of resist that lifting of the tile off the roof. And then you can also have metal roofs, which you can also get hurricane rated ones with appropriate anchorage. The next thing is the layer below the roof cladding material, and that's the roof sheathing. Oftentimes in a historic home you'll see this type of roof sheathing, where you'll see these sort of battens that are not a sort of a continuous roof sheathing membrane, and the tiles will kind of span across those battens. You can strengthen that by essentially replacing these with a continuous plywood sheathing material, and it could either be replacing, or it could be just putting over top and having long enough screws that go down to the framing that essentially makes a more robust roofing. So this is obviously during a fairly major re-roofing project that this would make sense. I'll make a comment here about the fasteners. And generally sheathing is nailed down, just because nail guns are easy to use and it's cheap and easy. And that's okay if your nails are long enough. But in some cases, especially if your frame doesn't have a lot of depth to nail into, it might be more effective to use screws. Screws are actually better in withdrawal. And so that might be an option if you've sort of got some limitations in the framing. So next thing we want to do is we want to connect the roof framing down to the walls. And I've pulled a page out of the Simpson catalog, and Tim Waite's sitting in the back corner there. He's the expert from Simpson. You can talk to him about all his fasteners later on. And I've circled some of the ones that you could use to connect essentially the roof frame, the rafter member down to the top plate, and then down to the wall stud. So there's really two main, I won't get into all the details of each one, but there's two main ways of doing this. There's this type, and the photos are fairly small, so you're probably not going to see the details, but you can connect the rafter directly down through the top plate and down to the stud. And so that's basically making a direct connection from the rafter down to the stud. Or you can do it as a sort of two-part system where you can use maybe this type of fastener, which connects the rafter down to the top plate, and then another type of fastener that connects, like this one, that connects the top plate down to the stud. And this would be necessary if your rafters are offset from your studs. Now this is obviously difficult to do unless you're doing some kind of resheathing project, either from the outside, you're residing the outside of the project of the building, or from the inside if you're doing an interior renovation, you've opened up the drywall and you have access. Some of these things can be done from up in the attic, but it's a little bit more limited. It's important, and I won't go into the details here, but it's important to use the right type of fasteners if you're using these connectors. And this is a table from the Simpson catalog. I've got it in the resources later. I've got a link where you can download the catalog and look for the specific fasteners for a specific type of connector. But it's important to use the right types of fasteners. And again, for withdrawal, for lifting up, for sheathing, lifting off the roof, screws are generally stronger. But when you've got a situation that most of these connectors are designed for, generally nails are just as strong, or if not stronger, than screws. Simpson does have some fasteners that are specifically designed with a special type of screw called a Simpson SDS, or self-drilling screw, and those sort of have the best features of both screws and nails. So those ones tend to be the strongest types of fasteners, and that's all the details I'll get into for that. And these ones are really designed for your sort of conventional stud wall type house. So some historic houses are built with conventional stud walls. Others are more single wall type houses where you've just got this single layer of boarding which basically forms both the interior and the exterior wall of the house. For that type of house, then we can use this specific hurricane clip that Barbara already mentioned that can connect your rafter down to your wall trim, which will in turn be connected into the vertical members of the boards. So there's sort of two types of clip. There's one that uses the self-drilling screws, and you generally only need one of these for each rafter, or there's one that uses nails and it's a little not quite as strong, so you typically use two of them. And this is sort of where they would be applied. So basically up here at the rafter, you connect it down to the top trim piece that would, and the fasteners would connect through to your vertical siding. If you don't have enough room for that trim piece, you can put another trim piece underneath it, and that might help to do that, make that connection. So the next thing is connecting, coming down the building, connecting from the second floor wall down to the first floor wall, and you can use this type of strap to make that type of connection. Again, it's probably going to be done during an exterior residing type project. And then lastly, and this is becoming a little less important because you're now getting down towards the bottom of the house and you've got more weight on your structure, but you make sure that your wall studs are connected down to your foundation. And there's a number of different ways of doing that as well. Sometimes with some houses you'll see this type of fastener, which we don't actually recommend anymore because they tend to corrode. So it's good if you are looking at your fasteners and you do have some, check the corrosion on them, and they might need to be replaced. If you've got the type of house that's a post and pier type house where the first floor is kind of elevated a little bit on some posts, then it's also important to connect that first floor down to those posts, and then you can do a further connection, which is to connect the posts to probably what is a new pier or a new little concrete footing. So this is an example of some connectors to do the beam to the post, and then this is an example of a connector that you might use to connect a post down to a new concrete footing. This is an example from an earthquake. It's not a hurricane example, but an earthquake, the 2005 Kahola Bay earthquake, and this is an example taken from the Big Island where the post has fallen off this pier. There's really no attachment between the post and the pier, and this is probably the most vulnerable type of foundation system that you can have. I actually had this type of system in my house, and I went and jacked the whole house up one post at a time, and basically poured new little footings and connected them down with fasteners because I was nervous about an earthquake or a hurricane blowing my house off these piers. So that's pretty much your complete load path. For flood, the only thing I'll mention is that flood's typically not going to affect the top of your house, or you hope it's not, and if it does, your house, there's probably not much chance for your house. But the main thing, if you're in a flood zone, is to anchor it down to the foundation. So that post to pier sort of retrofit, or the new foundation retrofit that I just mentioned, is probably very effective if you have a flood just running through the sort of the basement level of the house. And that's really the key thing that you can do for flood strengthening. So with that, there's a few resources I've listed here. I've got some links to the building codes, particularly if you're interested in maybe designing or building a safe room. There's some links to the building codes that have the safe room design requirements. There's a link to the film, the Luma film, and also links to the Simpson catalog if you want to download the catalog and look at the different connectors that you can use. And also a guide to the hurricane strengthening for Hawaii single family homes, which is a nice guide that sort of summarizes a lot of what I just